In the previous videos, we considered therapist. Now we're going to think about an example relating to baseball. And so specifically what we're going to be thinking about is the ability to hit the ball by individual players by position. In other words, do pitchers, catchers, and first base players, they all have the same ability, or don't they? So is position important in terms of ability to hit the ball? And then we're going to think about the overall general ability of a ball player to hit the ball. And so essentially we're going to have a hierarchy here where the ability of an individual player to hit the ball may be associated with the position at which they play, which may be associated with just the overall ability of a baseball player to hit the ball. So that's where we're going to begin. And so if we think about the data that we've got, here is the Excel spreadsheet, and we've got the players here, and the players have numbers. We've got 948 players, so these numbers are going to go from 1 to 948. They've got these 9 different positions. Here are the positions, and what we're really interested in is the number of hits they obtained relative to or as a proportion of the times they came up at bat. So we start off with this Excel spreadsheet, and we make a data frame called DF that's a little bit simplified. So instead of having this thing called player number, which is a really weird word, we're going to have player, which is going to go from 1 to 948. This prior position number, which I think initially was stored as a character, we're going to make that into a factor, and we're going to call it position. And then at bats and hits are just going to be transferred over. So our data frame is going to have these 4 variables, and note that position is going to be a factor. Initially, the levels may have been stored as characters, but now they're going to be stored as numbers. Here shows for the variable positions what each one of those numbers means. So what I want to do is compare the baseball example with the previous example of therapeutic touch. So when we did therapeutic touch, what we had as our likelihood function was a Bernoulli distribution with parameter theta that was indexed by therapist. And from that Bernoulli distribution, we obtain either series of ones or zeros, depending on whether or not there was a correct or incorrect guess about where the hand was located. So we had 28 therapists, so we had 28 different values of theta from 1 to 28, and those values of theta, those values of the Bernoulli parameter, reflected the ability of individual therapists to detect where the hand was located. And then we had our prior. And our prior for theta was a beta distribution with parameters omega and kappa. And we placed a whole lot of emphasis on this parameter omega. And the reason for that is that omega was the mode of the beta distribution. It was the mode of this beta distribution from which the 28 thetas were drawn. So we're really focused on this omega. And then we had to have priors for both omega and kappa. We referred to those as hyperpriors, and there they are. So now let's think about our batting example. So we begin first with the likelihood function. Now up here it was a Bernoulli. In the case of baseball example, it's going to be binomial distribution. And what we're interested in is y. And y is the value for hits. So we've got hits and we've got at-bats. And so y is going to be hits. And the likelihood function is going to be a binomial distribution that's going to be parameterized by n, which is at-bats, and theta. And theta is going to be indexed by player. So we're going to have theta 1 to theta 948. And we can think of theta here as being the ability of the individual player to hit the ball, very much analogous to the fact that theta here was the ability of an individual therapist to detect cancer. And recall earlier on this idea that a Bernoulli and a binomial are not really that different, because you can think of a Bernoulli as being a binomial with n equal to 1, or you could think of a binomial as being n independent Bernoulli trials. So that was our likelihood function. Now we need to have a prior for theta. And the prior for theta is going to be a beta distribution with parameters omega and kappa. A couple things worth noting. First of all, we're really going to be focused on omega, because that's going to be a reflection of hitting ability. But perhaps more importantly to note is that omega is going to be indexed by position, which means that we're going to have omega 1 all the way to omega 9 for the 5 different positions: pitcher, catcher, first base, etc. The reason that omega is so important is that omega is going to be the mode of the beta distribution from which these different thetas are going to be derived. So there was our prior. Now we're going to specify a prior for our prior that's going to be a hyperprior. Now up here we just had these fixed hyperpriors. Now what we're doing is we're going to say that the hyperprior for omega, and our focus is going to be on omega, our hyperprior for omega is once again going to be a beta distribution, but it's going to be parameterized by omega 0 and kappa 0. And again, you can think of omega 0. That's what our focus is going to be. Why? Because that's the mode. This is the mode of the beta distribution from which the 9 different values of omega indexed by position are going to be drawn. And then we're going to need to have priors for both omega and kappa, and we can think of those as hyperpriors. So with that overview, now let's come back and see if we can make some sense out of this flowchart. So we're going to start at the bottom, as we always do, and there is our likelihood function. And the whole idea of our likelihood function is the number of hits for the 948 players is going to arise from a binomial distribution that is indexed by theta, and we're going to have a separate theta for each player and the number of at-bats for each player. And that's what we saw up here. So we've got hits, we've got at-bats, and we've got thetas, And all these things are going to be indexed by player. That was our likelihood function. And then we've got our prior. And so what we're thinking about is the prior for theta. And we said that was going to be beta distribution with parameters omega and kappa. And again, our focus is going to be on omega. And we note that omega is going to be indexed by position. So we're going to have 9 different omegas, one for each one of the different positions. Why do we focus on omega? We focus on omega because that's the mode of the beta. It's the mode of the beta from which the individual thetas are going to be drawn. But again, the key thing is that different players may have different omega values here depending on the position which they play. So that's our prior. And now we've got to have our hyperprior. So we've got our hyperprior. And what I really want to focus on is the hyperprior for omega indexed by position, because that's the real key. And that also is going to be a beta distribution that's going to be parameterized by now omega 0 as opposed to omega and kappa 0. So if you think about what this omega 0 is, it's playing the same role that is shown here, the general ability of therapists, shown here, the general ability overall baseball players to hit the ball. So that's just the general ability of a baseball player to hit the ball. And once we've got that done, then we've got to go around and get our hyperpriors, or hyperpriors, there, and there. So that's just an overview plus flowchart. And in the next video, we'll see if we can't convert that into some code.